The sixth question says, find the intervals in which the following functions are strictly increasing or decreasing. There are some parts of this question. And find the intervals in which the following functions are strictly increasing or decreasing. That's what we are supposed to find. Okay. So, this function fx, let's call this fx equals x square plus 2x minus 5, which gives me f prime x is equal to 2x plus 2, which is 2 times x plus 1. Can you note that? Yes. And mark the critical point, this is minus 1, right? Here the function will be, here the derivative will be positive, here the derivative will be negative, and on the basis of this you can say that fx is strictly increasing for which values of x in this interval? For x greater than minus 1, or which can be written in this interval, in the interval format as, which can be written in the interval format as for x belongs to minus 1 comma infinity. Okay, this is what you can comment for minus 1 comma infinity. And similarly, fx is strictly decreasing for what? X belongs to less than values, less than minus 1 values, that is minus infinity comma minus 1, and you have open brackets. This is the final answer for this part over here. Let's continue further and see the second part of the sixth question. And what does that say? That says that we have to check this function and similar thing for this function, that is increasing, strictly increasing and strictly decreasing. So let fx is equal to 10 minus 6x minus 2x square. Okay, so this tells me that f prime x, the derivative will be equal to 0 minus 6 minus 4x. This is what you will get, right? The derivative of 10 is 0, this is minus 6 and this is minus 4x. You can take out something common from here, you can take out minus 2 common from here, and this will be 2x plus 3. Please note that this is minus 4 is minus 6. Yes, this is 2x plus 3, and the critical point is 3 by 2 with a minus. The critical point is minus 3 by 2, as you can note from here. This is a point where f prime x is equal to 0. Okay, so beyond this, in this interval, you can observe that this will be positive, but overall value will be negative, and here the overall value will be positive. Therefore, fx is strictly increasing for this interval over here, that is x belongs to minus infinity comma minus 3 by 2. This is what you can note. Fx is strictly increasing for this, fx is strictly decreasing for x belongs to, what you can say is strictly decreasing minus 3 by 2 to infinity. This is what you can comment. This is minus 3 by 2 comma infinity. That's what you can say, right? This is the final answer for this question over here. Let's see the third part after this. The third part, C part, says check this function. Okay, in the C part, this is given. Let fx equals minus 2x power 3 minus 9x square minus 12x plus 1. This is what we have. Okay, and this tells me that f prime x, the derivative of fx, will be minus 6x square minus 18x minus 12. Do you see that a factor of 6 with a minus will come out common from these terms, and what will remain is x square plus 3x plus 2. Okay, let's factorize this. Let's factorize this using splitting the middle term. This can be done as 2 times 1. This is 2 plus 1, right? So x plus 2, x plus 1. This is the factorization of this, right? And can you note that f prime x will be 0 at x equals to minus 1 and x equals to minus 2, right? At minus 2 and minus 1. Okay, so for values greater than minus 1 in this interval, for x, let us say you can take x equal to 0, for example. X equal to 0 will imply this is positive, but this is negative. So overall factor will be negative. For this interval, you will have, let us say 1.5 minus 1.5. This will be negative. This is positive, negative. Negative and negative will become positive. Okay. For values less than minus 2, let's suppose minus 3. This is negative. This is negative. This is also negative. Overall negative. This is what you'll see, and therefore fx is, what you can comment, strictly increasing for x belongs to, strictly increasing for this interval where the derivative is positive, -2 comma -1. And you can also say that fx is strictly decreasing for this interval over here, this and this. So fx is strictly decreasing for x belongs to -infinity comma -2 and -1 comma infinity. These are the intervals for which the function fx is strictly decreasing. This is the interval for which fx is strictly increasing. This is part C. Let's see the part D now. The part D says 6 minus 9x minus x squared. This is the next function that we have. Okay, we are supposed to check the similar thing. So let fx equals 6 minus 9x minus x squared. Okay, this is not 9. This is 6 minus 9x minus x square, and this gives me f prime x is equal to 0 minus 9 minus 2x. Okay, I can take out a factor of minus common from here, and what will remain is minus of 2x plus 9. Okay, the critical point, as you can observe, is minus 9 by 2, where this derivative is 0, right? 2x plus 9 equals 0 implies x equals minus 9 by 2. And for values beyond this, in this interval, this is positive, but this is negative. Here, the sign will change, right? This is what you get. And therefore, you can comment that fx is strictly increasing for x belongs to which interval? Strictly increasing over here, that is -infinity comma minus 9 by 2. You can also say that fx is strictly decreasing x belongs to this interval, which is minus 9 by 2 comma infinity. This is what you can comment, and that's the complete solution for this part D. Let's discuss part E next. This is part E. What does it say? X plus 1 whole power 3 and x minus 3 whole power 3. This is the function. Okay, that's an interesting one. Let fx be this function. X plus 1 power 3, x minus 3 power 3. Let fx be this function. Okay, this gives me that f prime x will be equal to what? F prime x will be equal to, you'll have to apply the product rule first. Okay, let's keep this constant x plus 1 power 3 as a constant. Let's differentiate this. Okay, so differentiating this will be done with the help of chain rule. So this will be 3 times x minus 3 whole square, and the derivative of x minus 3, which is 1, which is pretty simple, right? The next term will be plus the derivative of this, keeping this constant, the derivative of this. So x minus 3 power 3 will remain as it is. Derivative of this will be 3 times x plus 1 whole square, and the derivative of x plus 1 will be 1. Now, can you factorize this derivative f prime x? Yes, you observe that x minus 3 whole square, x minus 3 whole cube, this can come out common. Similarly, x plus 1 whole square, x plus 1 whole cube, x plus 1 whole square can come out common from this term and this term. Another factor of 3 can also come out common. What we'll get is x plus 1 whole square, x minus 3 whole square, and in the bracket what will remain is x plus 1 over here times 1, and here what will remain is x minus 3. Okay, this is what remains, right? So let's simplify this further. 3 times x plus 1 whole square, x minus 3 whole square is what I'm getting, right? And what will this be? This is 2x minus 2, is it? Yes. This is 2x minus 2. Can be factorized further? Yes, we can factorize this further by taking out 2 common from here, and therefore this gives me f prime x will be equal to, you take out 2 common from here, 3 times 2 becomes 6, and this is x plus 1 whole square, x minus 3 whole square times x minus 1. Yes, is that so? Yes. And now the critical points will be 1, 3 and minus 1. -1, 1 and 3 marked on the number line in this manner, right? Okay. For values greater than 3, let us say, let's take for example 4. This is positive, this is positive, this is also positive. Overall sign will be positive. For values between 1 and 3, let's take for example 2. This is positive. This is 2 minus 3, which is negative, but there's a square, right? So this also, overall this value becomes positive. Positive, positive, and 2 minus 1 is also positive. The overall sign is positive. Yes, you can comment on that. Okay, and what happens for this interval? Let's take x equals to 0. This is positive. This is being a square, this also becomes positive. And 0 minus 1, this is negative. So overall value is negative, I suppose, right? For values beyond -1 on this side, you have -2 for example. This becomes -2 minus 1, which is negative. -2 minus 3, negative square is positive. Okay, so negative into positive. This is -2 plus 1, which is negative square is positive again. So negative, positive, positive will be overall negative. This is the sign scheme for the derivative f prime x. Okay, and on the basis of this, can you comment the intervals in which the following functions are strictly increasing or decreasing? Yes. Therefore, fx is strictly, the first part says strictly increasing in which interval? I see that f prime x is positive over here and over here. So, if x is strictly increasing in x belongs to 1, 3 and another interval, that is 3, infinity. This is what you observe, right? Is that okay? Yes. Next, you can say that strictly decreasing in which interval? Strictly decreasing implies you will have to note the sign of f prime x negative. So you get the negative sign in this and this interval. Therefore, x belongs to -infinity, -1 and x belongs to -1, 1. Those are the intervals in which the function fx is strictly decreasing. That's what you can note over here. Now, a small comment, I can add a small comment over here. Some texts, in some texts, okay, not the NCERT, but in some other textbooks, you may find that since the derivative is only becoming 0 at one particular point, yes. So, people may comment that strictly increasing for x belongs to 1, infinity will also be true in this case over here. Okay, since this is a discrete point over here. That's what some texts may offer you. But from the point of view of NCERT, this is the final solution that we require. And yes, this is all that you have in this question over here.